Okay, here's a complete example of illustrating the pipe command execution, which accomplishes inter-process communication between two child processes. Um, so pipe. So let's look at the code and step through it. So pipe file descriptor creates an array of two file descriptors which are pretty much unidirectional data channels that are then handed off to the kernel that uses them to buffer input that is written into the offset 1 of the file descriptor, and reading from the pipe is accomplished by reading or connecting the pipe to the offset 0 of the file descriptor pipe. So here we basically told the kernel, create me a pipe that is using this array of file descriptors. If you fail to do so, give me an error. So now let's look at how the children are executing these commands. So here is a first child, so I will fork off a child, check, make sure that I'm successful, otherwise I will print an error. So here is a code for my child, for the first child, so as long as the PID is 0. Then I will take the standard output of my child and connected it to the writing end of the pipe that I handed off to the kernel, so to the buffer right end of the pipe. If I am unsuccessful rerouting my dupe2 file standard out to the file descriptor pipe, then write an error. So now from the user end, I can close the pipe or close both of the pipes. So this is a small routine that I created over here, which takes the array of file descriptors, and once again this is from the user end because kernel is still holding on to the pipe that I originally created, and that's where the buffer actually gets implemented. So I will close the file descriptor 0. If you fail, give me an error message. I will also close the file descriptor array offset 1. If you fail, give me an error message. So let's go back to the child 1. So then what I create is a command that will be executed by the child 1, which will be concatenation of a file pipe.cpp. And once again, const strings have to be copied onto a heap. So I create duplicate the string, which will take the constant and create a memory allocation by malloc on a heap. And the resulting pointer gets stored into the array of chars that I created to keep track of these strings. Then all subsequent arguments are written into, once again, constant string copied onto a heap, pointer saved into argument 1. And to terminate this array of char pointers, I will in a arg offset 2, that's where I will save the null pointer. So now if I execute the actual command is in the offset, is pointed to by the array pointer or by the string pointer saved in the array offset 0, and all of its arguments are in the rest of the Argus construct. So now that gets executed. If you fail, then give me an error message, but we also have to clean up after ourselves because once this child terminates, so I'm doing all of this in a child, once this child terminates, the heap allocation of 3 pointers string pointers that I created, that has to be deallocated. Also, all of the string duplicates that I created on the array have to be freed. So I will just run through every single offset of my array pointers and free each of the arguments. And finally, I will also delete the array itself. So this is the array of 3. And then if something happens, exhibit a failure. So that's what the child 1 does. Concurrently, there is a code for child 2. So the child 2 is first off forked off, and make sure that I am successful creating the second child. If I fail, print an error message. Now check that you are talking to the second child. So the second child will, as the first thing, it will disconnect its standard in and reconnect it to the reading side of the pipe that the kernel is handling. So whatever the child 1 wrote into writing pipe side, it will magically appear in the reading side of the pipe that the kernel is handling. So then from the user side, I can close the file descriptors because kernel is holding on to that pipe construct, and I create a execution of a new command tail. So for that, I will create an array of char pointers. And this command is just tail, so it will read the end of the file. So I will copy the construct, the constant string from the stack onto a heap, save the pointer into the array of char pointers offset 0, and also terminate the sequence of char pointers with a null, and finally execute. So I will execute the command and all of its arguments. Well, there's no arguments right now. And similarly to the child 1, if something bad happens during the execution of the command, I will give an error message, and I have to then clean up after myself. So I will delete the heap strings, but also I will delete the char pointer array that I created to pack my command. So notice nowhere here I told the command where to read from. All I did is repointed the file descriptor standard in to the reading side of the pipe. So whatever was written by the child 1 into the writing end of the pipe is then read by this child from the reading end of the pipe. And finally, parents will destruct all of the pipes after the children are finished, and wait for the children to finish, and once they are finished, then it will terminate. So as far as the execution goes, the child does execute, the first child executes catenation of the pipe.cpp. So it will pretty much just print the file pipe.cpp on the screen. And then the implementation is piping the output of this command as the input into the tail. So tail shows only the last, I forgot what's the default, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of the file. So this is the original file that we have, and if we count up 10 lines, there's a 10 lines that then tail processes. So that's what the kind of the default shell does. Let's see what actually our code does. So make pipe, and output should be identical. And as a matter of fact, it is. So the pipe, the first child called cat on pipe, wrote it into the standard out, which was really redirected and written into the writing end of the pipe. Then child 2 grabbed the standard in, but didn't grab it from the standard in, but grabbed it from the reading side of the pipe. And process tail, which read automatically from the rerouted standard in, which was the reading side of the pipe, executed the tail command, and then cleaned up after itself. And of course, parent waited for the children to finish, so it would not create zombie children if the parent would prematurely close before the children would be finished. So similarly, I can go and this can be any arbitrary number of commands. So I can have some additional parameters here. So if I don't want to print only 10 lines, I can print 15 lines of the tail. So if I recompile this and rerun, we can see that now the second child executed tail with the argument -15. So it took not only 10 lines of the reading end of the pipe, but it took 15 lines and printed the 15 lines of the reading side of the pipe. So here is a simple execution of how shell and the kernel implements the pipe on the kernel side by rerouting children's output into the writing end and children's input into reading end of the processes.